This is TechSNAP, episode 384. Hello, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems, network, and administration podcast. This episode was recorded on September 20th, 2018. My name is Wes, and we are ever so lucky to be joined with the one, the only, Jon the Nice Guy. Hello, Jon.
Hello there. It's a pleasure to be here.
Yeah, it's great to have you. You've got all kinds of expertise, and you're doing us a huge favor by volunteering your time, helping us out while Chris is away. So, how are you doing today?
I'm doing very well, thank you very much. And how about yourself?
Oh, I'm doing splendid, and it's nice to be talking to you. I guess we can just get this episode rolling. We've got all kinds of good content to talk about. The latest news, of course, some things you don't want to miss and you should look forward to. And we're going to talk about IPFS. But before we get to any of that, well, I've got some disappointing news if you have to interact with the U.S. government or any of the states. The Government Payment Service Incorporated, a company used by thousands of U.S. state and local governments to accept online payments, because of course that's how it works, well, they've leaked more than 14 million customer records dating back at least 6 years.
Yeah, it's not good, that at all. So the internet's IPS, Krebs on Security, on September the 14th, they notified GovPayNet that they had at least 14 million customer records going back to 2012. Now, apparently, it was only a couple of days later, the company said it had addressed a potential issue, but it's still not great, is it?
No, it's really not. And as they say here, the company has no indication that any improperly accessed information was used to harm any customer, and receipts do not contain information that can be used to initiate a financial transaction. And, well, that's true as far as it goes, right? They do have things like names, addresses, phone numbers, and the last four of the credit card. Now, that's not generally enough to, as they say, initiate a full financial transaction, but boy, that's a lot more personal data than I want exposed.
Yeah, with the amount, when you're looking at systems like these sorts of records, it doesn't take a genius to start saying, well, you can pull information together and sort of knit these various sources together to produce quite a complicated map of personal information, enough to do anything like from, take over an iPhone account all the way through to, potentially huge amounts of wire fraud and things like that. It's not great. It's not great at all.
It's just frustrating how simple this was, because anyone could access these receipts. They were just given an incrementing number that you could type into a URL and access. So you knew how to construct valid ones. If you had one, you could find others by decrementing or incrementing that counter, and there you go. There are other strategies if you don't want to have these receipts behind a login. Like Google Photos, for instance, has a giant namespace of potential file names, and you get, just like a random pointer into that big namespace. So you don't know how to construct a valid identifier. And while in theory you could find someone else's pictures randomly, the search space is just too big. But clearly GovPayNet has not spent any time thinking about this or any engineering hours to develop a secure system.
No, and from the looks of things, a lot of companies start their system without thinking about putting people's information as kind of like the privacy of that information as a forethought. So obviously, as many of your listeners may be able to tell, I'm from the UK, and we've just gone through the GDPR piece,
right? And
that mandates that you have to put data privacy almost as the very first thing you think about. You have to engineer it with security in mind, and if you don't, you're liable for huge fines. Now, obviously, this GovPayNet, it's an American firm, so it's not bound by GDPR. I do hope that none of the employees that are affected by this were either EU citizens or, needing to view this information from within the EU, because potentially GovPayNet may be looking at issues with GDPR now as well.
That is a great point. And with these kinds of services, of course you're trying to serve your customers' needs, and you want to make it easy, probably in this case, so that people could easily look up a receipt and, be able to reference that for whatever they need to do with it. That part's good, but you're right that you have to start thinking with security in mind. And much like, when you're crafting a firewall policy, start with the minimum stuff you can get away with and only add on when you know that you actually have a need for those ports to be open or for that information to be exposed.
Yeah, so if you're a web developer, please start from basics. Don't increment by one for every single record. Don't just assume that the next record, in fact, you should have tests in your system that check to see whether if you just increment by one, do you get another person's records? Because if you do, you might need to go back to basics on that one.
Well said. And it just shows that we can no longer assume that people won't be looking for these, right? We live in a dangerous internet where if you put something out there, some bot somewhere is going to scrape it, if not a more malicious actor. So you really, really have to think that way and be prepared with that mindset from the outset.
Absolutely.
Now, last week, we talked about Magecart. In particular, on the TechSNAP program, we were discussing their recent attack on British Airways and all the trouble that caused. Well, I don't usually fly with British Airways. You may, Jon. But one site I think might be a little more popular with our listeners here. Well, that's Newegg, and they, I'm afraid, are the latest victim.
Yeah, and from the looks of things, this Magecart group are actually going after quite a few targets. So whilst this is quite a well-known name, I have seen on a few different security sources that there are some others that they've gone after. But from the looks of things, a lot of this stuff is quite a well-engineered set of attacks. They are standing up legitimate-looking domain names. They are injecting JavaScript and passing the traffic from the legitimate-looking websites towards another legitimate-looking website. So in this case, they had certificates acquired by Magecart, issued by Komodo, who are a well-known SSL certificate vendor. These are not the sorts of actions of a malware group that are just doing hit and runs on whatever they can target. These are quite clearly very well crafted attacks against all sorts of firms. It's quite scary, to be quite honest with you.
Yeah, it is. I mean, they're having so much success, and this is exactly the sort of breach that turns people who already don't really trust interactions over the internet. It really drives them crazy because, of course, you're scared that all of your personal details will be leaked, that your credit card information could be stolen, because that's what keeps happening. And you're right. Like in this particular case, the Magecart group registered a domain name called neweggStats.com. And, well, if you didn't know that wasn't a Newegg domain, it certainly looks like one, especially when they haven't a verified certificate for it.
Yeah. So from the looks of things, the JavaScript is actually being loaded into the payment pages and is scraping the contents of things like the long credit card number and things like that. So they are actually getting, as I think you mentioned in the previous show, they're getting the full long number on the front, they're getting the expiry date, they're getting the CVV on the back. And these are things that if they were actually attacking the databases in the back end, they wouldn't be getting that information. So the benefit in quotes, the benefit to them is that, they're not having to go after protected databases because they wouldn't get the CVV number if they had that.
You're exactly right. Yeah, you shouldn't be storing those things. So you shouldn't have those. And probably on the back end, ideally, maybe you've spent a little more time on your security posture. You have more checks and balances. You are making sure that you've scrubbed sensitive data where you don't need it. But on the front end side, those could be completely separate teams. They may not audit it. And I mean, this JavaScript here in this case was 15 lines. So if you're not carefully watching, your checksums or who has access to that repository, how it gets changed, maybe it's really easy to change it on the production servers and you just, you append to that one JavaScript file and suddenly everything your customer types into their payment page, well, that's theirs now. I do wonder if there are any, simple steps people might take. I don't know if you have thoughts on this, if you are running something that handles these sorts of transactions, how can you make this simpler, or how can you have better guarantees that this sort of attack couldn't take place on your site?
So you're looking at it from two sides of things, aren't you? You're looking at it from the server side, and you're also looking at it from the browser side. From the browser side, I think even if you were running something like GhostScript or AdBlock Plus, you probably would have been affected by this anyway, because it's not a known malicious site. The fact that it was scraping data is not hugely controversial, I would say. If you were, say, for example, using, a JavaScript Web Analytics, having a piece of JavaScript that is looking at what text is being typed into a box, that's very similar to, the sorts of things that your analytics side of things do. So from a browser, I think generally you've got problems anyway. There's not much you can do.
Right. Unless you're one of those people who runs no script or really limits sites, but you may not even be able to make a successful payment if you're so limited.
Very much so. Very much so. From the other side of things, though, from a server side, obviously I don't know how their infrastructure is architected, but having a clear continuous integration process, having code reviews before code's started up. You don't know whether this is down to a malicious actor taking control of, say, for example, one engineer's machine, or taking control of part of the pipeline. So you really should try, if you can, to check things like, if you're using systems like GitHub or something like that, to have your code repository, make sure everything like two-factor authentication switched on, try and do PGP sign signatures for your code commits, make sure stuff's going through a CI/CD system, and if you are making a pull request against something that's not part of that library, so maybe potentially have a look at how your code flows go through your CI/CD systems, and make sure that perhaps if you're touching lots of different files at once, that perhaps it requires greater level of inspection. But again, I don't know what the systems look like, so I could be talking rubbish on that one, I'm afraid.
Right. Unfortunately, especially with today's complex systems, there's a lot of places where this could slip in. And if you haven't done that hard work of establishing good chains of trust from trusted workstations with keys, as you're talking about, and then knowing, having ways to verify that, all right, if we can trust source control, how do we know that that's actually what's running on our production machines? If you don't do any of that, well, it makes it pretty easy for these sorts of attacks. Really, it all just goes to show that, you got to take security seriously. Hopefully, there can be one. Firstly, I guess I should say here, if you are a Newegg customer, this attack went on for almost a full month. So if you bought anything in the last month, definitely go make sure you're checking your credit card statements. You should be doing that anyway, of course, but especially right now. The other thing, I hope that one upside of these horrible incidents will be that companies start taking this seriously, because this is not great PR. It's easy to have happen, and there's no other fix than to, really think about security holistically and make it part of your development process. Now, that's one way you might lose your information out on the World Wide Web. This next story hits a little closer to home. I don't know about you, Jon, but I think a lot of our listeners, well, their local NAS setup, that's something that matters, right? That's where you keep your data. That's where you might do local backups as one part of your backup system. And oftentimes you've set up, it's running other services. It's a gateway to your network in some cases, and it can be a huge vulnerability. Today's story, well, if you're using Western Digital's MyCloud devices, watch out.
Remco Vermeulen is the security researcher that looked into this, found a privilege escalation bug in the MyCloud device, where actually the dashboard of the device didn't check the user credential properly before giving an attacker access to the tools that in theory would require higher level access. And with that access, you got a complete bypass of the admin password on the drive. You got full access to the user's data. This isn't the first one of these sorts of attacks, but it is the most recent one. Now, apparently it wasn't only this researcher that found the information. It was independently found by another security team who also released exploit code. Vermeulen also posted a proof of concept video on Twitter, which is an unusual way of doing it, I suppose.
It does make his point pretty well that this is easy to exploit.
Absolutely. So part of the reason I think why he released this proof of concept video was because he actually reported the bug over a year ago and the company stopped responding to him. One of the things that Project Zero has done is kind of make this 90-day turnaround on responding to things. So it's now classed as the industry accepted responsible disclosure guidelines, is 90 days, which is for a large company is potentially quite a short period of time to have to deal with it.
Yes. I mean, I think many companies would like a little bit longer timeline, but the pressure's on now.
Yeah. And if a good guy has found something, you can more or less assume that he's not looking at it because he's just gone and figured he'd fuzz some some checks against a credential screen. Most of the research into these sorts of things tends to be kind of because something else has prompted it. So if the good guys are looking at it because something's prompted them, you can absolutely guess that the bad guys are looking at exactly the same set of evidence that's prompted you in this direction. And more or less, you're gonna realize at that point that maybe it's worth looking at the same thing. And as I said, found independently by another security team. Who's to say there weren't some bad guys looking at the same thing at the same time?
It really is troublesome, this kind of not necessarily low end even. I've seen these devices used at a lot of the smaller businesses, places that maybe don't have dedicated IT staff and want this functionality. And then where it especially becomes troublesome is, oh, well, I had to work from home today and they don't really know how to set up a secure VPN or anything like that. So they end up exposing these devices to the internet. And in this case, even if you did a good job and had set a really secure, strong passphrase, well, it just didn't matter because all you do is you set a cookie that basically says, hey, I'm admin and I'm logged in as admin. And there you are. You're admin. So Western Digital might be good at storage. You can have your own opinion about that. They certainly don't seem good at making a managed service like this.
I would say that the current guidance is that there is no fix for this and that users have to literally just disconnect the drive altogether if they want to keep their data safe. So those firms that are using the MyCloud, I'd make sure you've got it unplugged by the end of this show.
Yeah, absolutely. It's really just not worth risking your data. Go look and try to find some better things that you can place your trust in, or hire a real professional who can help you set up a network that you can have a little more trust in and hopefully explain just why some of these tactics are so easy to exploit.
So I think with that, we should move on to the main topic in this show, which is talking about IPFS. Now, the reason why this subject's come up is because Cloudflare is doing what they're referring to as a week of security on their blog. And one of the recent blog posts that they published is Cloudflare going interplanetary, introducing Cloudflare's IPFS gateway. And I've been looking at things like IPFS and Tor for quite a while. And in fact, actually, the initial blog post from Cloudflare actually does show a 4-box diagram which shows accessing websites behind Cloudflare without any of these technologies in place, and then saying that they're introducing services around IPFS and Tor. But as I said, IPFS is the main thing that I wanted to talk about. Now, I don't know whether it's been mentioned on this show before, but what I thought I'd do is actually have a little bit of a look at what IPFS is and how it works.
I think that's a great idea. We haven't done much talking about IPFS. It's been a technology, floating around. It's definitely interesting, but whether or not this is a good move or not by Cloudflare, I've seen a lot of arguments on both sides. People already invested in IPFS, maybe a little skeptical of Cloudflare taking this big role and being in the middle of a lot of these connections with their new gateway. But on the same time, this is garnering a lot of press for IPFS, and it is a technology with a lot of potential.
Absolutely. So one of the key things about IPFS is that the reason it was introduced was because they were looking at the fact that it doesn't take a lot of effort to lose a website. So one of the things that's on their front page is, remember GeoCities. The web doesn't anymore. I don't know about you, but I certainly spent, many years crafting, the best animated GIFs that man could scrounge from the internet.
I mean, it's a rite of passage.
Absolutely. That under construction sign. One of the things that IPFS does is it takes a block of data. So that might be your web page itself, plus any images, maybe a collection of web pages, and it effectively creates that block as a content ID lump. And that is then pushed into the IPFS, this interplanetary file system. It's marked with a content ID, which is effectively a hash of that blob of data. And then in theory, I could then send any one of you a link to, whatever your IPFS gateway is. So you can run an IPFS binary on your local machine and access localhost, or you can use Cloudflare's gateway. There are other gateways that are out there. And then suffix that with /IPFS, IPNS, and then the URL for the hash that you wanted to get. So that means, for sake of argument, if I create a blob of data and pass it around, that's then out there for as long as it's being accessed by the internet. Effectively, it's cached on all the machines of the people that access it. And it's a little bit like BitTorrent. In fact, I'm sure that a lot of the inspiration from this came from BitTorrent, in that all the people that are accessing it are then acting as seeders for that information again.
Right. So you can go, if you're running, especially if you're running a local version of this and you go to access it, it can go pull that down. But once you've pulled that data down from the network from some other node that's already hosting it, well, you're effectively hosting it too. Absolutely.
And so obviously, because of the fact that's a hash of a specific blob of data, and realistically what you want is not so much, the equivalent of, document 1 dot version 1 dot old dot really old dot, oh no, it's current dot com or whatever.
I would never use that naming scheme. Oh, come on.
Would you not? No, never. But it's, rather than like addressing a specific version of a file, what you actually want to do is address, mywebsite.com. So what you can do with IPFS is use a thing called DNS link, which is where you inject a DNS text record pointing to a IPNS, so that's Interplanetary Naming System record, and that's a mutable link. So where effectively in the back end of the system, if you've got a hash which is, say for example, dead beef, and you then have this IPNS, this name reference, which is decaf bad, if you then change your content ID from dead beef to AB, sake of argument, and you tell it that that's the same name, it effectively just updates the pointer. So it's almost like the git head and the git tag methodology for those that are comfortable with the git way of things, or just, as I said, having a file which is, .new, .really new, .really new.
Right. Yeah. I mean, you can think of it as updating a symlink to the latest release of something or the latest version.
That is probably a much more sensible way of looking at things. Yes.
It's interesting too. Like I think I'm personally a big fan of this approach to having immutable values, and you can have mutable references to those values, but you know that you won't lose any of those past versions, right? You don't modify in place. You make a new version, it gets a new hash, and you update your pointer.
Yeah, absolutely. And actually, one of the benefits to this is that it means that static content lives, in theory, forever, particularly, high value content. So I know that when the WikiLeaks stuff was being released, for example, people were sharing that sort of content on IPFS, knowing that that content would then stay for as long as it was being accessed. But obviously, stuff being accessed doesn't make it last forever. What you actually want is something to say, I'm going to keep a copy of this, and effectively be like a persistent seeder, again, using the BitTorrent terminology. So what you can actually do is you can either run lots of nodes yourself and pin that content on all those nodes, which means, so for example, if I've got my content on my home system and I have a server in the cloud, what I could do is access that content from the server in the cloud and then pin it. So then I have 2 points of resiliency. Well, for some organizations, 2 points of resiliency isn't enough. You want 10, 15, 1,000, 100,000, whatever. And what you could do at that point is then contract out to firms to pin that content for you. And in fact, it's actually called out in the IPFS documentation as being one way of making money as a service provider for IPFS.
Right. Basically saying like, look, I have storage and bandwidth, and if you need files, I can add them. And then you don't have to worry as well, right? You don't have to worry that they're going to modify it or have insider access man in the middle of you because, well, it's all identified by the hash.
Absolutely. That's exactly why it's a brilliant system to be looking at. So obviously the next thing that most people look at when they're looking at websites is, although they did reference GeoCities, people don't really tend to want static websites anymore. They want dynamic and flexible content.
Yeah, right. I mean, you're changing all the time. You're working on a new project. You want to tell people about it. All kinds of stuff. Stuff happens, and you want your website to reflect that.
Or even if you wanted to do something like, have user comments and stuff like that. So actually, in the background of IPFS, there's a system called PubSub, which stands for Publish and Subscribe, and that is eventual consistent database that runs inside the IPFS system. So I can publish something into this PubSub system, and it will pop out to anyone that's subscribed to the same output to that. A group of coders have taken that as a basis, and they've developed a thing called OrbitDB. And in fact, there's an excellent example of using OrbitDB on the GitHub page for the OrbitDB project, where they basically say, run two browsers side by side, go to this web page, and you can see it establishing the connection over IPFS, and then having like blog post comments, hello from, with lots and lots of different people posting into that. So if you're looking to build a dynamic system on top of IPFS, then you might want to look at using Orbit as your database layer that sits on top of that.
Right. And it's not, in many ways, this isn't you do need some higher level tooling to replicate everything that we've been doing on the centralized web, but IPFS can provide this base layer of technology that we can start building more of those tools on, and just have this peer-to-peer idea more at the core and not be reliant on centralized infrastructure, or at least less reliant.
Yeah, and the guys that have created IPFS are also looking at lots of other distributed technologies as well. So it's not just IPFS. They're involved in, I think, the Namecoin project and things like that as well. So there's lots of different technologies that they're involved in, they're working with, and that they're trying to make it so that we're not all reliant on the Facebooks and the Googles of this world, even though their code is largely hosted on sites like GitHub.
Right. And another interesting thing I noticed going through this is just, it doesn't even necessarily have to rely on the public internet. If you have your own, if you have your own private networks that you're running, well, IPFS could function on those just fine.
Yeah, absolutely. So for example, if you're working for an offline network, as long as you've got nodes that can see each other, they can use IPFS, they can communicate over it. And they basically set up this overlay network that lives to transit the information around it. And that's a really powerful way of publishing. Again, you're not reliant on a core set of servers to service your content for you. It's down to, potentially your fans, if you're producing works of art or code commits and things like that. There are IPFS Git repositories, so you can commit your code into Git in IPFS, so then you can be pulling from that without needing to use HTTP or HTTPS, without needing to use a service that exposes the content you're looking for.
Yeah, it also seems to me that we've gone so far with our centralized infrastructure, but in many ways we've ended up reinventing things that we wouldn't have to spend so much time on. Now, not to say that you wouldn't need to do these things, but we scale out infrastructure. We have complicated load balancing setups. We try to set up various levels of redundancy, but because it's all on top of a centralized system, we end up with all kinds of DNS hacks and IP layer hacks just to get this to work and seem consistent to the end user. With IPFS, it just feels cleaner, right? You're like, well, nope, I added it. A bunch of nodes have pinned it, and you just ask the network, and well, one of those nodes will serve you the content. Another thing I have enjoyed while experimenting with IPFS is it's just really simple to get started with. The main implementation is in Go, so you can just go download a nice static single binary you can run on your system. The tooling's really easy, especially if you're already familiar with the command line. You can do stuff like IPFS cat, and then you paste the hash that you're interested in, and it pulls it from the network, prints it to your standard out. So all these tools already work. It fits very nicely into a Unix-based workflow. And you don't have to, you can use Cloudflare's new gateway. You can use the existing gateways. But if you really want to start playing with it, I would go install the daemon and just start adding some of your files and see what it's like.
And like you said, if you are looking for a simple way of exploring it from a command line, there is also an IPFS files command. So where we mentioned before about having this mutable content system with an immutable data layer, with the IPFS files command, you can actually explore the files that would be in that blob just from a shell, and you can edit, create, change your files, and then effectively commit that immutable blob into your immutable file system. There's also an implementation in JavaScript. So if you wanted to use JavaScript, like a JavaScript web app, single page web application or something like that, you can use that to work back and pull information from the IPFS network, or you can use Node.js to integrate IPFS content into your JavaScript based command line or GUI applications.
Oh, see that? That would be really handy. You don't even have to rely on some native binary if you've got JavaScript access. Well, who doesn't? It runs just about everywhere. One interesting thing is, you can be skeptical of what Cloudflare's motivations are here, but they've done a lot of work trying to make their gateway work well. So they've re-implemented some things. They've taken some time to write even a DNSSEC client to make sure that when you use their service, which of course does let you tie into some of their fancy product offerings and take advantage of their edge network for good or for bad. But they've obviously cared about that, right? And they want to help you run nice services. If you do use some of their services, they're making it pretty easy to go get your own domain name and start hosting stuff on IPFS with Cloudflare as a fancy cache at the edge, but getting verified content out of the network and then serving it over SSL.
So I've had a bit of a poke around at the Cloudflare IPFS front end, and it's definitely a very easy way of exploring IPFS.
Don't think of it as the only way to do so. Hopefully it's just one way that can make this neat technology more accessible to people. But of course, the main benefit is you don't need this. There's other gateways and you don't need a gateway. You can start playing with it right now on your home machine without having to sign up for anything.
Absolutely. It's definitely worth giving it a good try.
Thank you, Jon. That was a lot of great information. You're probably wondering, audience, how do you go learn more? Well, we've tried to make it easy. TechSNAP.systems/384. We've got all kinds of links. Cloudflare has their own documentation, which does a pretty good job of introing this. Of course, there's IPFS.io, which have their own guides, plus some stuff like how do you go about running a blog? Well, we've got examples of that and links to other projects that you might want to use either with IPFS or examples of cool products based on IPFS. Or, hey, if you've already used it, you want us to talk more about it, or you want to just brag about the cool stuff you're doing with it, we'd love to hear about it. TechSNAP.systems/contact. As much as I would love to talk about IPFS all day, we do have a time limit on this show, so it's time for our final thoughts. First up, just a little security notice for all of you Docker users out there. There's been a bit of an issue with Alpine. Now, Alpine is the teeny tiny lightweight Linux distro that is very popular for Docker containers. It has a small userland, doesn't take up a lot of space. People love that. Unfortunately, well, they've had a bit of a problem with their package manager, which meant that all Alpine-derived Docker images are suspect.
So like you said, Alpine Linux is a very tiny distribution. Most of the time you're looking at like 5 or 6 meg for it. They've got a packaging system called APK that sits on top of that. This APK application, you can actually make it exit with a 0 exit code by writing to proc and then the process ID /memory, which means that you can install packages during the installation. You can inject other commands into it and it will still exit as though it's built properly. So what this means is that as an attacker could intercept a package request. So say, for example, you wanted to install Node.
I really do want to install Node.
Exactly. You want to install Node to run your JavaScript hotness. You've downloaded the APK package using the APK tool that's built into Alpine. It downloads this tar gzip file. So it unpacks the archive and then runs the suspicious code. So apparently malware can escape detection by being hidden inside the commit hooks directory, which is a bit of an unusual place to put code, but I guess that's probably where you're looking at it. So fortunately, a patched version of APK is now included in the latest version of Alpine. So anyone that has got a Docker image that is running with Alpine on it is encouraged to go and rebuild their images. And probably because Alpine is such a fundamental part of how a lot of people are working with Docker, the guy that found the vulnerability is suggesting making a donation to Alpine. Aside from anything else, they've got one main developer for APK, and he fixed that bug in less than a week. And the lead maintainer, who again is part of a small small collection of people managed to cut a new release of the distribution within a very short period.
That's really impressive. And I mean, Alpine underlies so many containers, many of them running on, private cloud services out there. People don't even necessarily think about it, right? You're 6 layers deep in Docker inheritance, but it's all pulling in Alpine somewhere. This story is interesting for a couple of reasons. One, it's a good reminder that, you gotta check where your Docker files are coming from. Two, well, package management is tricky, and it's always wise to think about when you're installing a package, whoever's authored that package, or in this case, something could be man in the middle or a malicious mirror. They have root on your box while that package is installing. In this case, there's some issues with not really checking things before all that extraction took place, and some quibbling with symlinks and hard links and making it work so that you could get files maliciously on the file system. So watch out there. And third, you have no excuse not to rebuild this. Docker makes it so easy. Just go to your CI system, trigger some new builds, test them, and push them out.
I've not done an awful lot of stuff with Docker, but like you said, creating a new build in Docker is such a slight piece of work. And Docker is designed to be very low, not necessarily low maintenance, but low impact to make changes to the system. So it's definitely worth giving it a rebuild if you can.
And as you said, go give some support to Alpine. They're doing great work. They're helping make Docker better. So if you rely on that technology, try to throw some bucks that way. That's going to be about it for TechSNAP 384. Thank you so much for joining, Jon. This has been so much fun. In particular, I'd like to point people to your excellent podcast, the Admin Podcast, adminpodcast.co.uk. So where else can they find you?
I am pretty much on all of the centralized social networks as Jon the Nice Guy. So please feel free to look for me there, or I have a blog at jon.sprig.gs. That's sprig.gs.
And that's Jon with no H.
That is Jon with no H, although I will answer to emails that say Jon in my name. You
are just so gracious. So thank you again for joining us. If you want to get all the details about this episode, that's techsnap.systems/384. You can find the whole network over at jupiterbroadcasting.com or on Twitter at JupiterSignal. I'm at Wes Payne, and thank you so much for joining us for this week's episode of TechSNAP. We'll see you next week.